All right, so once again, today we're talking about the properties of powers. So before we get started on talking about the properties of these powers, let's talk about what a power is. If you had something like this, m to the third power, the entire thing is called a power. So once again, the entire thing is called a power. Now there's two parts of this power. There is this part here, which you sometimes have a variable, like in this example. Sometimes you have a number there, but that is called the base. And then you have this little number up here, which you're all familiar with. That is called the exponent. So a power is made up of a base and an exponent. And we can have a variable for the base, or we could have a variable for the exponent. Or we could have a number for both of them. But we need to know that those different parts are there, and the whole thing is called a power. Okay? So the first property that we're going to talk about today is the product of powers property. It's kind of a tongue twister. Product of powers property. Product of powers property. What does product mean? It's the answer to a multiplication problem. So we're going to see multiplying here. All right, so we're going to see a multiplication sign, but there's very little we actually multiply here. Let me show you what I mean. If we have a power, m to the a power times m to the b power. In both of these powers, they have the same base. That is extremely important. The base must be the same. Base must be the same. So in both of these powers, our base is m. Okay? So the only way this property is going to work is if your base is the same. So if the base is the same, you're going to keep the base. So in our answer, the base is still m. And we're not actually multiplying. We're going to add the exponents. That's our second step. Add the exponents. So we would do a plus b. And that would be our answer. Now we're going to do some examples that have actual numbers, okay? But that's kind of like your formula. So again, one thing we need to remember is that your base must be the same in order for this property to work. You keep your base in your answer, and you add your exponent. So even though this is a multiplication problem, we are really not multiplying any part of our powers. Okay? So let's do some examples with that. Let's say we have n to the fourth power times n to the third power. My base is what? N. They have the same base, so in my answer, my base is n. My exponents are what? 4 and 3. What do I do with my exponents? Add them. So I'm going to go ahead and show the work, even though this can be a mental step that you do. Again, that can be a mental step, but I'm going to show it up here in my notes. I'm doing 4 plus 3, which is 7. So n to the 7th power is my answer. Pretty easy, right? So you can have more than just 2 powers that you're multiplying together. You could do this with 3 powers. No, I don't want to do the third again. That's x. I try to make my x kind of fancy so it doesn't look like a multiplication sign. So this works, you could have 10 powers. It doesn't matter. It works the same way. As long as your base is the same, then it works. So your base is a fancy x. You can do your x however you want. And then we're going to do 4 plus 5 plus 2, which would be x to the 11th power, yes. Now, honestly, every book that I've ever seen usually starts out your powers where your base is a number, but that seems to make people more confused. So that's why I started out with our base as a variable, because it makes it a little bit easier, I think. But I'm getting ready to do some examples where our base is going to be a number. Stephen, you have a question? No. On your homework, you will not have to do any problems where the bases are not the same, but I just wanted you to know that this property is only going to work when the base is the same, okay? All right, so what I was talking about with making things look more confusing, when your base is a number, like you have 8 to the 7th power times 8 to the 5th power. Some people see the 8 times 8 and they want to say 64 to the 12th power. But remember, you keep your base. So whether your base is a variable or whether your base is a number, you don't multiply your base. You keep your base and you add your exponents. So 8 to the 12th power would be your answer. Okay, so again, that's something that a lot of people make a mistake on, is they want to multiply their bases. Don't ever multiply your bases. Okay? What are we going to do if we have something like this? Keep your base. My base is 5. What is the exponent here? When I don't see an exponent, is it a 0 or is it a 1? So we know that an exponent means how many times it's repeated, right? That this is really 5 times 5 times 5. There's 1 here, so it's 5 to the first power. They're never going to show a 1 there. So you need to know that if you don't see an exponent, there is an exponent of 1 there. If you had 5 to the 0 power, if you ever see 5 to the 0 power, that equals 1. It doesn't equal 0, it equals 1. Okay? So if you ever see that, 5 to the 0 power, or anything to the 0 power, it equals a 1. Alright. So again, 5 to the 1 plus 3, so it would be 5 to the 4th power. Yes. 1 to the 0 power would still be 1. Good question. Alright. I want to talk about another word that you may know this word. That word is coefficient. It's a algebra kind of word. Coefficient. Does anyone know what a coefficient is? It goes with something else. A coefficient is a number in front of a variable. Like if you had 6m, the 6 is considered a coefficient. Okay? It's the number in front of a variable. So a coefficient is a number in front of a variable. Now we're going to be talking about that word a lot this whole year, and you'll talk about it when you get into algebra next year. Okay, those coefficients are important. It's important that you know that word. You're comfortable with that word. So we can still do the product of powers property when we have coefficients. Okay, so we're going to do that. And there is an additional step you have when you have coefficients. So let's say we had 5m to the 3rd power times 4m to the 2nd power. Now before we were just doing m to the 3rd times m to the 2nd. We didn't have coefficients. So we have this extra step now. And this is where we are going to multiply. We're going to first multiply our coefficients. Multiply your coefficients. then everything else is the same. Keep your base, add exponents. Multiply your coefficients, keep your base, add your exponents. So those last two steps are the same. So in this problem, what are my coefficients? 5 and 4. So I actually want to multiply 5 times 4, which is 20. My base is m. Keep it. My exponents are 3 and 2, so I'm going to add them. 3 plus 2 is 5. And that is your answer. So you multiply your coefficients, 5 times 4. You keep your base, m, and then you add your exponents. 3 plus 2 is 5. All right, I'm going to give you one of those to do on your own. You ready? Yes? No? Maybe? (4y to the 8th power times 6y to the 5th power). Alright, so first thing that I hope you did was 4 times 6, our coefficients. 4 times 6 is 24. My base is y. I'm keeping my y. Adding my exponents. 8 plus 5 is 13. So that is my final answer, 24, y to the 13th power. We feel okay with that? Not that hard. Okay. I think what I am going to do, because I know we have 12 minutes left, I'm going to do some more with the product of powers. I'm only going to give you for homework the product of powers ones, and then tomorrow we'll talk about the quotient of powers, and then we'll finish up that paper. Okay? So let's do a couple more things about product of powers, and then I'll tell you exactly which problems to do on your homework. It won't be the whole thing. All right, so we're kind of splitting it up into 2 days because I'd rather take a little bit more time on this. Because I want to show you what would happen if you had something like this. So your problem right now is a to the 3rd power, b to the 4th power, times a to the 7th power, b to the 2nd power. When you see anything like this, I want you to kind of think of it in 2 separate parts. Okay? We said that this only works when your base is the same. So we have 2 powers over here. We have a to the 3rd power, and we have b to the 4th power. On the other side, same thing. These are kind of, even though they're right next to each other, we need to think of them as being separate powers. Okay? So look at just your a's first. A would be a 3 plus 7, which is a to the 10th. And then your b would be 4 plus 2, which would be b to the, and that is your answer. So we're looking at our a's only in both terms. Those are called terms, by the way. A to the 3rd, a to the 7th. So we keep our a, 3 plus 7. There it is. So again, that was my yellow one. And then we're looking at our b's. For our b's, b to the 4th, b to the 2nd. So 4 plus 2 is 6. There's that. And they just go right up against each other. So even though they're right up against each other, they really don't affect each other at all. Okay? It's just like they're buddies. Let's try another one of those. Made this a little bit harder. You're probably like, great. How many different bases are there? 3 different bases. So match up your bases. You're doing 3 separate things. Don't let them confuse you. Okay, so we had our m's, we have our n's, and we have our p's. Okay, so again, we need to think of this as being three separate things. So for our m, we have 5 plus what? 5 plus 8. What is 5 plus 8? 13. There's our m's. Forget about your m's. Done. Check. Check. Now let's look at our n's. So for n, we have 6 and what? 1. Remember, this is a 1 over here. You don't see it, but it's like an imaginary 1. So it's 6 plus 1. So n to the 7th power. So now our n's are done. And last, we have our p's. What exponent does this p have? A 1. So p1 plus 6, which is also 7. So final answer is right here. M to the 13th times n to the 7th times p to the 7th.